we've got a full and exciting plate today. We are very much excited to share with you the December product focus training with not one, not two, but three NPIs this month. So three new product introductions for you to look forward to, and some diverse products. So just a reminder, I would encourage everyone to please mute your microphone. So please mute your mic so we don't have any background noise there. We are going to start off today with the TB4. TB4 is an automotive grade FFC to board connector. It's a 1 millimeter pitch connector, and Chris Tubbs is going to walk you through that product, and that will be followed up by the LF Cat 6A connector. So that guy is part of our popular LF series, and that obviously is Cat 6A version. So a high-speed Ethernet support for that connector. So that's an exciting one to add to the product lineup. And then the kind of cherry on top of the cake is our new millimeter wave, RF millimeter wave products. We've had a really good, reliable series in this product category in the past. The special thing that's really kind of special, or the unique feature, is that these guys are field replaceable. So this opens up a really some new market opportunities for you. And Mark Warren is going to walk you through all the details on those. So without further ado, I am going to pass the baton over to Chris Tubbs to take us away. Chris, it's all yours.
Okay, thank you, Scott. And for those of you that don't know me, I'm Chris Tubbs. I've been with Hirose for a number of years now. Right now, I am part of the technical support group out of Chicago. And I am also kind of a dotted line with regional sales engineer for Region 10 and Region 60. So that territory is pretty much everything Denver West. But just a little background on myself. But as Scott said, yeah, these are some kind of exciting connectors, and I don't want to paint myself as a connector nerd or stuff, but sometimes when you see stuff, you look at it and go, hey, it's actually pretty cool. And starting off our cool connectors today is our TB4 series. So TB4 is primarily think of it as a wire to board connector, but it's basically board or wire flex to board on there. Last month, I know Nate, who's doing our LF series today, touched on TF7 or ZK1 series, and today we're going to do TB4. So they're similar, but they're definitely different. A hallmark of Hirose stuff that while they might seem similar, they typically, a lot of connectors that are similar, they've got different attributes to them, and that's kind of what allows Hirose to play well into a lot of different markets, is that we do have those different types of variations to it. So kind of an overview or comparison chart here for ZK1, TF70, and TB4. We won't get into ZK1 or TF70, but big things with TB4 is that it's a single flex connector or single flex circuit connector. It does have a US CAR rating on it, which is important, and we'll get in that into a little bit. Right now, we've only got a 16 and 30, but we do have 10 and 22 under planning, and depending on if there was a particular customer that you had that needed a particular pin count and we can do it, we could definitely look into that. So they're not necessarily limited to what we're doing right now with it, but it's kind of what we've got currently and in the wings. So as Scott had said, it's a 1 millimeter pitch center lock FPC to board connector. And it is for kind of automotive the connector kind of has come out of some of the requirements that we have seen in especially EV type vehicles where they have been trying to reduce weight in the cars with traditional wire and cable on it. Most of that wire and cable, once you add everything up, it can get really heavy, and kind of the arch enemy in vehicles or aircraft or something has always been weight. So the heavier it is, generally the less efficient it is. So the lighter you can make it, the farther you can go on, given a quantity of fuel, whether it's an electric charge or if it's, jet fuel onto it. It does reduce size and it does reduce assembly time by being able to do this. Like I said, it does have US car compliance to it. It's got a high contact reliability with kind of a 2-point contact mechanism. It prevents electric shock, kind of the way everything is nestled or nested into the connector. It's kind of finger safe. And we do offer two guide keys on it, both a standard one that's black, and then there's a kind of a gray option as well. So some of the advantages of the two-piece FPC to FFC board connector here. On the left, we've got your traditional discrete wire connection. So you had to take the wire, you got to cut it, you got to strip it, you got to terminate it, then you got to populate the housing with it. Whereas on the FPC side, I mean, once that flex is made and you've got the other two pieces, the plug housing and the retainer, you're pretty much in business. There's nothing really else that has to be prepared for it to be able to make the assembly. It improves workability because it's kind of an all-at-once thing. It saves space on some of these once you get it in because it is a much flatter. It does reduce some of the bulk from a traditional wire type connector. And again, we get the weight reduction from going from discrete wire to the flex circuit. Kind of some of the pieces in here, we've got the receptacle side. There is a retainer, the TB4 30PR-1, and also the plug itself, which is kind of the business end of this, the TB4 30P-1F. Some of the simple dimensions here on it is fairly compact. It's 4.5 high, it's about 8 millimeters, 9 millimeters deep. And with the mated connection on it, it's about, roughly about 1/2 inch deep. So it's not a terribly bulky connector on this. Some of the US car requirements. So US car is an automobile standard for most vehicles. And typically the connectors will be submitted to US car and they're tested, and once they pass, they get the US car requirement, in this instance for both heat and vibration into it. So the vibration, is more of an automotive standard. You can see the frequency here on it and also the shock resistance on it. So the takeaway here is you might not necessarily have customers that need an automotive grade connector, but maybe they've got something that does have, a lot of vibration, or maybe it's higher heat. So even though they don't necessarily have to have a connector that meets a US car standard, they can benefit from the requirements that for the heat and vibration on this. So two-step operation on this. One, the first thing you do is you just get the housing. You take the flex circuit, traces go up on this, and you just insert it into the housing. Step 2, once the flex is into the housing on it, you just take the retainer, and the retainer slides in and snaps over the housing on it. And at that point, once you're done with that, it's kind of locked into place on it. The flex does have to have a notch on it, as you can see here. Actually, you can see it right up here because there's kind of a little projection or a little nub in there on the inside of the plug housing that will kind of lock into. And that will also help with some of the retention feature on it, but also the retainer. The retainer also makes sure that the flex is securely seated to its proper depth, and that if there is somehow it gets pulled on or something inadvertently, it's going to transfer that stress to the connector and not necessarily to the flex connector. So there's an extra bit of insurance there and reliability. Speaking of reliability, so the high contact reliability, there's a 2-point contact structure in this. The first one kind of will be pushing any dust or debris out of the way. And then the second contact is, pretty much touching as clean of surface as it can get at that point. Also, if this first contact, maybe it gets damaged somehow or broken, you still have the second contact in there making contact with the trace on the flex circuit. So it's kind of a redundant system backup, and again, it feeds into that whole high reliability feature. Prevents electric shock. As you can see here, there's kind of a feature on it where it keeps any fingers from touching the contacts on it. And this is on the board side connector. On the flex side or the cable side, the contacts are recessed and they're kind of down in a trough, and you kind of get these ribs between each one of them that are kind of anything that would maybe get in there to kind of touch it or arc across it, it's not going to happen. So they're kind of buried in there. So they're very safe from electric shock, and even from mating it, you're not going to get that necessarily that any type of a shock or problem from there. The 2 guide keys. So this is one of the things that typically US car likes. The auto industry likes different colors for connectors, and they also like different mating options. The benefit, if it's not in an automotive application, or if they don't need a second connector on there, if the customer was using 2 of these side by side for whatever reason, or maybe they're using one, a set of connector or set in one portion of the design and something else in the other, they can actually have an A key or a B key on it, and they can be color coded so assembly personnel doesn't inadvertently mismate the connectors in the wrong spot on there. So the standard one is going to be a black colored housing with the keying position up in the upper left-hand corner, the B key, which is gray. Again, both the cable side and the receptacle side are going to be gray colored, so both of those will match. And the keying options are up in the upper right-hand corner. So there's really no way that it's 2, they're both they're color coded, and they've got a guide key or a mate in a particular spot on it to prevent mismating. Applications, definitely, I know we've talked about automotive, but there's probably a lot of other places that these can be used. A number of years ago when we brought out our flex circuit, the FH63, we had a heavy equipment manufacturer kind of adopt it for some of the displays inside the operator's cab on there, and it worked perfectly, but there's no reason why you couldn't use a TB4 in those type of applications where there's, constant rumbling, vibration, from the equipment itself. Even into stuff like, factory automation, storage batteries, they can use these kind of daisy chain batteries, certain lamps or lightings, battery management systems. So there's a lot of different applications that the TB4 and others like our ZK1 can fit into. Here's a typical application where they're using certain battery cells or batteries where they've kind of got these things all hooked together, and they're all drawing the power off each cell, and they're, so it's basically one continuous draw on that. One of the things that is good about the TB4 is that it does have a 1 amp current capacity on it, where most flex circuits are going to be rated at maybe 0.5, depending on what pitch you have. Some of the smaller pitches, maybe they're only 0.3, but with TB4, you can get, since it's got that larger pitch of 1 millimeter, you can get some fairly decent amperage or current going out of that thing because of the larger pitch. So it's kind of a best of both worlds there, where you get maybe more of the current capacity of, say maybe a 24 gauge wire, but yet it's in the package, it's using the flex circuit to, move that power from, point A to point B onto it. So it does have that attribute to it. So other than that, any questions, put in the chat box and we'll address those at the end. But other than that, that's about it for TB4.
Excellent, Chris. All right, well, that will transition us to the LF Cat 6A. And taking center stage now will be Nathan. Nathan, you're up.
Thanks. You guys see? Cool. So hello everyone, my name is Nathan Moskal and I am a technical product specialist from Hirose's Downers Grove headquarters, and I work on the product management team. I'm excited to share with you all a new product that we are offering called the LF Cat 6A. Some of you may be familiar with our LF series and thinking, hey, this isn't new, and that is true. But we are now offering a higher transmission speed variant of this series, capable of 10 gigabit per second Cat 6A Ethernet transmission. I will introduce this new product first, show some of the benefits of it and the rest of the LF series, and then give a little overview of the whole LF series for those that are unfamiliar. So here are the topics that I'll be discussing today. We're going to start with background on the development of this connector and this series, as well as key product features. Then I'll give an overview of the non-Cat 6 LFs, the market space that this series is targeting, and finally our competitors. So the story of the LF starts a long time ago in 1962, when Hirose made its first original product, which is the RM series, which we actually still sell today. It's a metal circular connector that was using screw locking, originally designed for radio equipment. And later, the HR30 was developed as a quicker to use and service plastic housing alternative to the RM. And the LF kind of combines a little bit of the old and a little bit of the new. It is a metal circular connector, but it's more compact than the RM and also benefits from a faster locking system, kind of like the HR30. The Cat 6A only continues this trend of improvement. So previously, the medium-sized shell, the LF10 in this series, was able to perform Cat 5e transmission. And now, in that same size, we've managed to fit in Cat 6A. For those that are unfamiliar, this is just a little overview of Ethernet standards. So this graph here, the blue line is the max speed in megabits per second for each category of Ethernet. And then the orange line is the bandwidth or frequency for that category as well. So with the introduction of Cat 6A in 2009, both of those increased frequency and speed. And this had only happened once prior with Cat 5's introduction in 1995. So although Cat 6A came out 15 years ago, and that may seem old, that's when the standard originated, not necessarily when it started to get adopted by the market. And it is actually the newest standard that is pretty popular within the US. Cat 7 is a EU-only standard. And once you get into Cat 8 speed territory, many customers opt for fiber optics instead. So Cat 6A is here to stay for a while. So like I said previously, the LF10 was able to support Category 5e Ethernet at 1 gigabit per second speed. And now we are jumping up a whole new magnitude to 10 gigabits per second with the Cat 6A. If the mating interface on the right side of the screen looks a little familiar, it's probably because you've dealt with M12 X-coded connectors, and we will discuss these later in the competitors section. So part of the LF series strength is its high quality electromagnetic interference shielding. The shield contained within the cable, either a braid or foil, is able to terminate to this spring contact here in red, and then all the way through the shell of the LF to the panel of whatever device it's mounted in. This circular spring ensures that even in rough or vibration-heavy environments, the shielding is maintained and ensures that the 10 gigabits per second connection functions with minimal noise and maximum speed. One benefit of this specific Cat 6A variant is that it can be very quickly assembled with just a hand crimper and a wire stripper. You don't need any soldering, and after the contacts are crimped, it's very, very easy to assemble. I was able to handle one of these samples before we released this product, and I was messing around with it, unscrewed some things, and got it all the way back to step 1 here. And it took me about 30 seconds to figure it out without any instructions. So it's very user intuitive. And like it says in the slide here, the wiring can be very consistent, even independent of the operator's skill. So another big value with this series is the waterproofing. So at every possible point in the connector where water could get inside, there's either a seal or a gasket or an O-ring, some sort of seal that blocks that water from coming in. And all variants of the LF series, including the Cat 6, are rated to IPX8. So they can be submerged in 2 meters of water for 2 weeks without any water intrusion to the inside of the connector. As with many of our series, there is an audible click when mating the LF connector. So as you can see on the left side of this slide, you push it's called a bayonet lock. So you push it on and you do about a quarter turn, and then it's locked. And you don't, unlike a screw lock, you don't have to do any torque management. It's very easy to do, very reliable. And this is the locking that's on the Cat 6A, as well as all the other variants of this series. It's intuitive to use, it's quick, and it's simple. So I mentioned the waterproofing, but the LF is also durable in outdoor conditions while still maintaining its sealing and performance. This includes 2,000 hours of sunshine weather testing and 500 hours of salt spray testing for the black chrome plated variant. If you have a customer that is interested in this black chrome plating for corrosion resistance, please note, as it says at the top here, that will remove the shielding benefit because that black chrome is not conductive. So if you have a customer interested in that, make sure they know that and make sure they're okay with that trade-off. One strength of the LF series is its variations. So these are the 3 shell sizes we have here, LF 7, 10, and 13. For each shell size, the series is available in both straight and right angle orientations. And the LF 10, which is the size that the Cat 6A is in, is also available in a low profile right angle option. Unfortunately, that is not for the Cat 6A, but for the other variants within that series. And that low profile option is a great option because it actually is die cast instead of machined and is going to be cheaper for your customers. One benefit of the standard LF variations, so not Cat 6, is the ability to have a hybrid connector. So you have both power and signal contacts that can do different amperages. So on the left is the LF7, the smallest shell, and on the right, the biggest shell. And both of those have hybrid options available. So here are the variations. I just mentioned those 2 hybrids. For the LF7, which is the smallest, you have 3, 6, and that 6 hybrid. LF10, which is the Cat 6A size, is available in 4, 8, and 12 pins. The 8-pin is the Cat 6A variant. If you have someone that wants that Cat 5e, they're going to need the 12 position. And then the 13 comes in either the 11 position hybrid or 20 positions. Some of the boxes here have checks. That means that they're available with both male or female contacts on either side. If it says male or female, that's the only thing that's available. And kind of like the keyings with the TB4, the ability to switch which side is male, the receptacle or the plug, can make it so that your connector that you want to mate in this spot only mates there. And it can sort of help prevent manufacturing mishaps with that. A lot of these variants are also quote unquote on request available. Those are the blues. So that means that these are not huge variations to existing products, but we don't currently have mass production capacity for them. So if you have a customer interested in them, let us know and we can figure out and see if we can get it to them. Here are the specifications for the LF. You do not need to memorize them. I'd like to call your attention though to the couple things circled in red. Firstly, all variants are rated to 1,000 mating cycles. So this connector is great for sort of I/O applications where you're going to be plugging and unplugging them a lot. And in terms of current capacity, it can handle a decent bit of current. Both of the larger shell sizes can handle 10 amps, and the smallest can go up to 5. And then for that temperature range, you're looking at 85 degrees C maximum, which is perfect for industrial environments. And that is the exact market that this connector is targeted at. So within industrial applications, it's suited for any connections where its high mating cycles complement its other features like shielding and waterproofing. So think I/O connections. Some such applications could be measuring devices, including medical devices, and factory automation control. So the Cat 6a market has grown a lot over time since it was released 15 years ago, and so too have the connectors available for it, both from us and our competitors. While RJ45 connectors, which is typical Ethernet plug, if you're not familiar, are fine for most consumer applications, there are many industrial use cases where they're simply not reliable or robust enough, which is what spurred the creation of the M12X coded connector, as well as this Cat 6a LF. For situations where robust, high-speed Ethernet is needed, the LF Cat 6a is a great option, and you should show it to your customers. It's pretty cost competitive in some analysis that I've done so far, and it has superior current capacity compared to the M12X standard, which caps out at 0.5 amp per wire, and we can do 2 amps. As with the Cat 6a variant, the LF has many metal circular competitors for its normal options, and it's slightly less competitive on price than the Cat 6 version, but it still offers that same robustness, shielding, and reliability. One of the big strengths of our competitors here is that a lot of them are these M8, M12, M standard connectors, and customers may be pretty accustomed to using them. However, it being the LF still has a more reliable locking and compact design compared to these. So try to emphasize these when discussing with your customers. If they're looking for an alternative to these standard connectors, the LF is a great option. So this is an example of what Hirose calls a door opener. These are application-based documents made by our segment and marketing teams that show where our connectors could potentially be applicable in a customer's system based on the type of product that they're making. As you can see here, the LF is perfect for power and signal and I/O connections within a motor. And if you were here last month, this looks familiar from the MT50 training, which is right next to it. If you're meeting with a customer about a motor product, show them the LF, show them the MT, show them anything that's on here, at least if they're interested based on the specs. And these kind of show the relevant specs to give you a quick and easy way to narrow down what you should pitch to the customer. And if you're unaware, you can find these door opener slides on hirose.com and on our extranet. Here's another one. This probably is maybe more applicable to that Ethernet than a motor would be. So the LF Cat 6 would be a great option if you're working with an industrial sensor or machine vision, factory automation camera customer. Pitch them the LF Cat 6a as a more robust alternative to a traditional RJ45 Ethernet and as a lower cost alternative to these M12X code connectors. So here's our first and only question. I'm going to give you guys about 30 seconds to think of an answer, and you can send it in the chat. Answer as many numbers as you think is true. So which of the following are benefits of the LF series? 1, it has a metal shell to shield against EMI. 2, it has standard M12 screw locking. 3, it is waterproof while unmated. And 4, it has a compact and robust design. Or 5, all the above. So I'll give you guys about 30 seconds now, and yeah. Send your answer in the chat whenever you're ready. Yeah, I've seen some answers come in. If you said number 1, said it does have a metal shell, then you're right. If you said 2, that's actually not true. The LF has that bayonet lock that I showed, not screw locking. Unfortunately, it is not waterproof while unmated. It has to be mated, but when it is, then it is IPX8. And it does have a compact and robust design. So if you said 1 and 4 only, you are correct. Thank you guys for listening. Does anyone have any questions? You can send them in the chat or unmute.
Hey, Nathan, this is Ed. Can you go back to slide 15 for a second?
Yes, sir. Find my nice 15.
Right. Yeah.
15.
Yeah, there. So point out, if you would, the different positions for the LF7 versus LF10 versus LF13, because they all don't have the same number of positions.
Yes, this is true. So the LF7 is either 3 or 6 positions, and I showed that hybrid so you can have different currents in that if desired. The LF10 is available in 4, 8, or 12 positions, the 8 being the Cat 6A, and the LF13 is available in either 20 or 11 positions, with the 11 also being a hybrid, where you have 2 different amperages that can go through that connector.
Thank you.
Does anyone else have any questions? What does LF stand for? Chris Tubbs says, I do not know, sir.
Okay. It was a question that was posed to me, but, and this is kind of more like Hirose, I don't know, trivia or something, but it was a question that did come in from another. But the LF stands for, believe it or not, little finger, because I guess when they were designing it in Japan and everything, I guess one of the Japanese guys looked at it and said, you know, that looks like a little finger. And so they called it, believe it or not, LF.
There's your fun fact for the day, everybody.
So you come to the Hirose product training sessions, and not only do you get insightful information into the connector and the interconnect space, but you get fascinating fun facts like that.
Yeah,
Thank you,
most
Nathan.
of those, most everything has a, like say if it's DF, like say DF11 or DF13, those are like, that stands for discrete fine, meaning like it's fine pitch and it's a discrete wire. But yeah, so we've got them, normally those letters mean something on it. But it was always fun that even when I found out that LF was little finger, I said, are you kidding me? It stands for little finger. And they're like, yeah, it's little finger. It's like, all right.
All right.
All right, well, thank you guys. I'll turn it over to Mr. Mark Waring to talk about the millimeter wave.
Take it away, Mark.
Okay, helps if I unmute myself. Okay, hope you can hear me, right, Scott?
Yes, I can. Yes, I can.
Okay, perfect. All right, so I'm going to introduce some products that aren't quite on our website yet. We're just in the final crossing T's and dotting I's to get these out. We've got NPI packages in the process of being sent to DISTI. So some of you on the call, hopefully we'll start to see these come across the board here shortly. You look at this slide, and this is just sort of a draft, flyer for the products. And you might say, oh, well, I already know about these. These are Hirose's millimeter wave. And I put it up here on purpose because they do look very similar. But hopefully after a few more slides, you'll come back and be able to immediately understand what the differences are. So we're introducing these, and the key word for these particular parts is field replaceable. That's just an industry standard term. Don't read too much into interpreting it literally, but they're called field replaceable connectors. We're also introducing just a new super high version of our test connectors, which are our existing solutions, and extended frequency solutions of some of our edge launch. But today, the entire focus is on this entirely new family of field replaceable millimeter wave solutions. So how do these new field replaceables fit into our existing family of products? Hopefully you've seen this slide, and I didn't introduce myself either. So I've sort of manage our RF product line from the marketing group's perspective. I also support our consumer electronics, and I'm based out of San Jose. But anyways, this is a slide that I always use, and these new products fit very nicely into our existing family of millimeter wave test connectors. They are slightly different in design, and as I say here, they're entirely different in terms of the types of markets that we're going to be going after. So that's where they're really the most exciting, really, about these, is that it is opening up an entirely new spectrum of potential target accounts that we, nor you, our reps, nor you, our disties, have been able to go after with Hirose in the past. So here's our existing connectors, just as a quick one-slide refresh. Our existing connectors are called test port or test and measurement style connectors. And these are used almost exclusively in customer laboratory environments, being placed on things like test boards or eval boards, where the point is just to test something else on the board, like the customer's own chips, for instance, semiconductors that they're developing. Now, they may be selling these types of boards to some of their downstream customers, but it's still in a test and measurement environment. These are never going into an end product out in the field. So just as a refresh, that's why they're called test connectors or test and measurement connectors. And that's all we've ever sold in the millimeter wave business so far. Field replaceable connectors look very, very similar. You hold them in your hand and you wouldn't really be able to tell the difference unless you look very carefully. But I'll show you what the differences are. And again, more importantly, they go after an entirely new market of finished RF module products, not test and eval board use. And I'll show you what that I mean by RF module as well. But first, the difference in the connector itself. On the very bottom is our existing test connectors. And if you look carefully, you can sort of see at the bottom of the connector, there's a male pin sticking out. For these new field replaceable connectors, instead of a male pin sticking out of the bottom, there's a female contact location. Our customers, or our potential customers for these new products, they will take these accessory products, which are sometimes called contacts or ferrules or glass beads. They're just a pass-through element, as you can sort of see. They'll tool those pass-through elements into the outer wall of their RF module, and then our new field replaceable connector slides right down on top of that extended pin coming out from the accessory product. What kinds of are these end products I'm talking about? These end products are mil-aero types of RF modules. They might be a RF splitter, an RF mixer, an RF amplifier. And these are real world images of the actual types of products. These are sort of cute little heavy ruggedized things that could fit in the palm of your hand. And the nice thing is you can see usually they have multiple connectors on them. Some of them could even have more than this, but certainly these are typical. You might have at least an in and an out connector. You might have, if it's a splitter or mixer, you might have 3 or 4 connectors on a single product. So again, this is very different in our current test measurement. They don't really lend themselves for our sales teams to forecast because they're not tied to end products. But now we are opening up the door to go after what would very nicely fit into our typical types of forecasted product model. So I think there's some new opportunities. Now there's no way these are new. These are industry standard type solutions, and there are multiple suppliers already. So we are definitely the new kid here in town trying to get a piece of this. Also, very interestingly, for many, I would gauge at this point from our early customer engagement efforts, I would gauge that over 50%, it might be significantly higher, of the customer sockets we're going after are currently using one dominant supplier. Their name is Southwest Microwave. They're based in Arizona. If you go to their website, you're going to see almost all they focus on is these types of connectors. Making them even more unique is that they also drive all of their business through one exclusive, what I call a boutique distributor named Hasco. There's even some historic ties between the two companies, but today they're completely independent. They have been for a decade or two. If you go to the Hasco website, you're also going to see they're almost entirely focused on reselling the Southwest Microwave parts. So for better or worse, at least we have a very clear picture of exactly who our primary and main competitor is in this market. And I think it's more better than not good, is that fact that we can look at this very specifically and know exactly how we need to compete to try to win business away from them. So with that in mind, as Japan worked on this and got our input, the decision was made, and I 100% think this is a great decision to have our first grouping of parts, and those are 6 different part numbers that we're getting ready to launch right now. Each of those is a drop-in replacement for one of the more popular Southwest microwave parts. So we're going right at we make with the same accessory type of pass-through products I showed that customers would already be familiar with. So how do we win business? Well, we know that we're going to have to be competitive on price, probably most importantly. We certainly have more than that. We think even our very robust U.S. disti network is going to be an advantage. Our onshore technical support, which Southwest Microwave definitely does not have, is already proving to be some advantage on some of our early customer engagement efforts. But pricing, no question, is going to be really on us to show customers that we can be competitive. And so far, what we're looking at, in our stack up of margins all the way through our disti network, we believe we're going to be significantly lower priced, or have the ability certainly to quote, if we choose to be significantly lower priced than the Southwest Microwave parts in the higher frequency 1.85 and 2.4. And what I sort of fuzzily say, we're similar on the lower frequency band, meaning at best we might be at around parity with the Southwest Microwave parts. But if I had to choose, I'm very happy that we're showing some more competitiveness on the higher frequency parts. That's where the industry seems to be moving more, and there's simply higher ASP opportunities for us to go after. Of course, Southwest Microwave is not the only game in town either, so I don't want to overstate that. There are several other suppliers already in play, but again, it's certainly also true that Southwest Microwave seems to be the best benchmark and the best supplier to go after. And one more sort of comment at the bottom is that while we're introducing 6 new products all in once, there are probably 50 or more different SKUs out there in the market. But the nice thing is most of those additional SKUs are very minor changes to the mounting hole size and location. We're already talking to one lead customer directly about doing a semi-custom version of these new parts to meet their preferred hole spacing. So that's entirely on the table. We're already trying to ID some minimum order quantities with Japan where we could do the same for any customer. So we believe we're going to quickly be fleshing out our SKUs to have a much more robust library. But we're also very happy with these first 6 that we're starting with. So where are these to be found customers? Well, we've been doing a lot of our own, and this is just a rough map. I didn't put the names because it wouldn't be appropriate since we're already working with some of you in our regions directly on them, but we're certainly will be more than happy to share names and whatever contacts we've got with whoever out there in disti, our disti network or our reps are interested in trying to step up and help make some engagement. But just here, it's interesting to see they do sort of cluster, these mil-aero types of suppliers sort of cluster in the Northeast, certainly probably the most dominantly. There are scattered important opportunities across the country in the Southeast and Texas. Another cluster out here in California, both in Silicon Valley and down in San Diego, which has a little grouping of mil-aero types of supplier networks going back, decades as well. These targeted customers include many in what we would call users. And you might say, well, 5-10K, that's not a huge volume. Hirose 20-cent, 30-cent micro board connectors. These are $20 to $40 types of high-end parts, and that's with our advantage versus the competition. So these are high ASP parts. If we take the middle road volumes of 10K, that's a nice $300,000 annual opportunity for a one given, good customer here. The other interesting thing customers from an existing supplier to Hirose, but as I just pointed out, and I even went to Octopart just to confirm that the other day, and Southwest Microwave just doesn't show up on any of our disti, product sites. So these are opportunities for any of us or all of us, hopefully together, to find some new business that's going to be additive for all of us. So that's sort of exciting too, I think. And I wanted to go quickly, so this is just the same slide I started with. Hopefully now, after those few descriptions, this makes a little more sense. It looks very similar to our existing test connectors. Over here on the left, upper left, the part numbers look very similar too. They do come in the same bands you maybe already have heard about, these 1.85, which we call the HV, the 2.4 band, which we just call 2.4, and the 2.92 frequency band, which we call the K band. And these are all industry standards, but in the new part numbers, you'll see just as clearly an FR in the part number, and that's for field replaceable. So that's how you'll be able to distinguish these parts easily. So again, these are coming in the process of getting ready to ask our disties to place initial stocking orders. We're very open. I know some of you disties even have dedicated individuals, or in some cases, individual teams who are focused on these types of mil, aero, RF types of customers. So we've talked to some of you. We'd love to re-engage and get your inputs and help identify and share with you some of these target customers and sort of get the wheels turning on seeing if we can get some engagements going. So that's it for me. If there's any questions, you can put them into chat or again, unmute and ask now. And Scott asked me to include these couple slides here. So turn it back to you, Scott.
Any questions before we, let me open it up for questions before we wrap up today's session.